messages and map overlays. And maintenance response, for maintenance response, they can have emergency, different categories: emergency, planned, strategic, and optimized. And then comes the compliance and SLA can also be taken care of with this implementation. The expected outcome is that 18 to 23% reduction in nighttime crashes would be there, and 96% reduction in data transmission cost also, because the technology which we are using is very cost effective, and we would be doing edge processing also. So load would remain very low. Predictive maintenance would be there, and we'll eliminate the energy wastage because we'll be continuously monitoring the lights, and compliance would also be there, and the infrastructure would be data driven, and decision making would become very effective, and strategic decisions can be taken in very less amount of time. Next, please. Conclusion: 28,774 continuous data points reveal true lighting conditions. Manual surveys miss out the critical issues, and each route presents a distinct hazard profile. So you can understand that within 48 minutes of drive, we can generate that kind of data, this kind of data. Imagine if we have such an implementation for the whole city or smart city, then what would be the dimensions, and how good we would be in maintaining the lighting condition, and how much the accidents can be reduced. It is by 18 to 23% of reduction would be there, and improved quality and perception of the pedestrians also. Benefits: life saved, energy optimization, maintenance saving, and data driven decisions. Thank you.
Yes, session is open for question. Audience. Jamud sir.
Yeah. The distance is generally between 30 meters to 35 meters. So we are categorizing that as a transition. So the category is transition. So that is recorded in our data. So 30 to 35 is the standard distance which is given, and if the lighting conditions are correct and they are the luminescence is as per the recommended norms, then it would not affect. We will have ample amount of light in between. Ten 10 readings per second. That is true.
We have just started, so because we have developed a device for that. Some light spot. Is there any company
So that's what the IoT framework which we are proposing. It is totally automated. Every data is being sensed every time, and 24/7 the dashboards would be given to the concerned person, like electrical people, municipal corporation. They would be knowing already beforehand.
discussed
Hmm.
that if there is speeding, immediately photo goes to the control room. So if similar kind of a things could be implemented.
So what we are proposing is that we are collecting data 24/7. So that information which you are saying will be sent in fraction of second, and it will be displayed and flagged on their dashboards.
It will flag on their dashboard also.
Yeah. And moreover, the lights which are about to fail will first produce flickers or signs of failure would be detected beforehand in these readings. So maybe a day or two before we'll come to know that these lights are about to fail. So that data would also be there and flagged on their dashboards. Not much, sir. Moonlight was not there.
Because the city of Delhi also has trees also. That shut. So there was no moonlight.
Sir, no.
It was not a mosque, but it was humid. Yes. Because moonlight also will not be
Vivek, your topic of the problem you have taken is very good. I have one query.
Yeah.
The sample data you is actually you collected sample.
25,000 something.
How it is actually collected?
How?
How the sample data collected for this light sample?
What we have done is we have used a sensor, light sensor.
Did you have any picture or any like of this?
Yeah, that picture was there.
So that picture we have not shown that because that is not painted.
Okay.
Yeah, that device will.
Picture. It doesn't. Because with picture you will come to know. Nobody will say that I can copy.
One more question, sir.
The two were working at the time of study. So we have data of two sensors, and both in the paper we have published that graph that both the data of both the sensors is at par. So no variation was noticed.
Thank you, sir.
The repeatability of what, sir?
Repeatability of this data. Did you conduct this experiment only once or you did it many times?
No, this was conducted only once.
That it doesn't tested this
It has to be at least 100 times. Before calculating the experiment.
The repeatability, sir, the parameter is fine. Repeatability must exist. Then
Yeah, that
it
is
will
true.
improve the result.
That is true, but what we were trying to do here is that with just 48 minutes of data, such kind of inference can be drawn by analysis. Then what we are trying to say is that if we move to IoT, imagine the dimensions, we can repeat it. That repeatability can be done. Maybe the data which has been taken, maybe at that moment few lights were off or some issues were there. Next time we may not get it. But the majority of the data would be like that because that's how the lights are in our streets.
Okay, thank you, Vivek.
Thank you.
Now I invite the next presenter, paper ID number 27, Mr. Nitesh. Continue.
Good afternoon, everyone. My paper presentation topic title is Blockchain Integrated Cybersecurity Architecture for Protecting the Sensor-Based IoT System. So, from the early morning to till we all are discussed about the IoT devices. So, now we in my research paper we discuss the concerns related to the cybersecurities and how we can overcome by using the blockchain technology. In this paper, I propose a framework where we can use a blockchain technology to protect our IoT sensor devices for the cyber attacks. So my presentation is going like that. It's follow the outlines there, introductions, problem statement, methodology, IoT blockchain integrated cybersecurity framework, and conclusion, future scope, question and answer session, and the references. Next. So we all are from morning. We discuss about the IoT devices. So in my left hand side picture is given that like many sensor devices that we are using daily daily uses, like smart cars, smart thermostats, smart home applications, smart speakers, everyone. So generally what happens in the IoT devices, they are generally sensor based, and we can use in the multiple applications like healthcare, transportation, and other human ecosystems. So we all know about like in this IoT system, IoT devices, yeah, they all are generally belongs to the centralized designs. Okay, they are generally collected in the cloud services. So Satoshi Nakamoto, and he proposed this blockchain architecture in 2008, where it can be collected. There is a multiple blocks are there, and it is a collections. It is a network where the multiple blocks are connected to each other, and it is decentralized. So when he proposed this model, the main concern that every in the networks what happens, it is centrally communicated, admin by the center. So when blockchain technology proposed, it decentralized. It means there is a peer-to-peer network when each blocks are connected to each other. There is a no central devices, no central admin who can order or who can operate it. So when it works, it generally works. There is some consensus are there that help us to validate our transaction that occurs in our network. So in this image, there are some images. In this image, some blocks are given. Like a block of chain is include like blockchain header, non-sum values, transactions, timestamp, and message routes. So generally, if I am talking about the blockchain, so each blocks are known by its hash values. Okay, and every block have some previous nodes from where it come. And it also records the timestamp when any transactions happen or not. So the main the properties of blockchain, I want to be inform you all, like it decentralized peer-to-peer networks, and there is some consensus mechanisms are there so that any transaction happen in the network, it should be fulfill the consensus, otherwise transaction not occur. And after every successful transactions, new block added. And there is a ledger system where all the transactions are record the transaction values, whatever the transaction, and it immutable. Not a single node are having power to change or change it or change it like alter it. Okay. So if there is want to be changed, we need the majorities of all the network majorities so we can change it. So now the problems. In this, starting from IoT devices, we all know about. Sir, also some of the speakers come earlier here. They talk about the cyber threats in the IoT devices. So generally, what happens, sir? The IoT devices are very small. Okay, so they have the specific design to perform their core functionalities. So might be there is the size is not stable, like size is small. So there might be chances to done some attacks, cyber attacks are there that can be changed or alter the data, manipulate data, or some weak architectural designs that limited to the scalability. We cannot scale it. Okay, and the dependency on the centralized system, maybe the single point of the failure that cause of the server down. We are facing sometime happens when our smart device is not working properly due to some down of our network slowdowns. Okay. So how we can use the blockchain technology to overcome all these problems? There is a proposed study. So here is how we can integrate our blockchain technology with the IoT device in the IoT based ecosystem to protect our IoT devices. So there is a multiple layers, you know, also that there is a user client, there is a IoT cloud servers are there. There is a bridge and the IoT devices. The 4 layers we can divide it here, so that in the first layer is that IoT device where we call our IoT devices are there. So we generally connect it with the server by using some bridges like Bluetooth, spectrums, jet waves, and then based upon this, our IoT devices connect with the servers and give the user the user client, how he use, it depend upon it. So we integrate the blockchain technology between the local bridge and the servers, so that any transaction that occur in our server, so it can record it and it cannot be changed there. And there is a multiple layers, like application layers, IoT blockchain service layer, and we can integrate our blockchain technology between the application layer and the connectivity layer. So here is a like traditional way where we can all like sort our IoT devices in the edge layer. It can connect it through the fog layer and the cloud layer. So in the cloud layer, between the IoT fog layer and the cloud layer, we integrate our blockchain technologies there. Here is some studies that discuss upon the many challenges are there, like manipulation risk, weak architecture, cost and capacity limits, and the cloud downtime, as I earlier discussed with you all. So some papers are proposed some solutions where we can use this blockchain technology to avoid this kind of the risks from there. So here is our proposed model. It's just only the proposed model where we can use our blockchain technologies to avoid the cyber attacks in our devices. There is a application layer where the administration, device management, task management, data visualization, that is all comes in the application layer. We integrate our application blockchain generally in between the connectivity layer and the application layers. So there is the properties of the blockchain, like peer-to-peer network, smart contracts, distributed ledger, consensus management, that all help us to avoid the risk that happens in the IoT devices. So rest of the other is connectivity layer is the same like as the fog layer and the IoT physical layers. So this is our proposed model. So this currently it's not implemented, just only the proposed model. So the conclusion of my paper is that whatever the problems we facing in the IoT devices when we connect it with the cloud layer, we can help using the blockchain technology. We can remove it, and the future scope is we can integrate with the real time so that we can implement such kind of a solution. Thank you.
Audience, any question?
Sir, Sir, applications like if I talking about the smartwatches, sir. So sometime what happens that our device is not working properly. Like if I talking about the smartwatches, heavy. So here we can use like any transaction happen. Like what if we communicate from our mobile to the smartwatches it directly, not maybe due to some viruses cannot be changed. अगर सर लाइक ब्लॉकचेन्स हैं तो वहाँ पे सर जो 50% अटैक्स को छोड़ दिया जाए तो फिर हमारे पास ज़्यादा सिक्योरिटी आ जाती है ब्लॉकचेन की यूज़ करने में. दैट्स आई होप.
Every attack is being lodged.
Right.
Every attack
Yes, sir.
is being noted.
Yes, sir.
Lodged.
Yes, sir. Because in this every transaction, whatever happen, so like if I send some transaction, some message to you, like our devices send to some cloud, message to the cloud, so it records, sir. And in the laser, it recorded. And every nodes, whatever the in the network is connected, it should be reflected there. So it helps us to it display all the networks, all the nodes there. So इससे हमें क्या कहते पता चल जाएगा कि whatever the things is happening there.
Thank you, Nitish.
Thank you.
Now, let me invite the next speaker, Mr. Sanvi Vasist, paper ID 43.
Good afternoon to everyone. Today we are students of the North Cap University and we are here to present our topic, 2 UAV system for post-disaster reconnaissance and autonomous delivery post. So the very first thing that might arise in your mind would be, why are we using 2 UAV when we can work with a single one? But the reason for this is that if we break down the work, then it would be really very easy, and because when we divide the work for both the UAVs, they have their separate working, which would be easy for them.
So our abstract for this would be disasters area face several issues like the loss of communication and as seen incapable routes, inaccessible routes. We can't access every time because of the disaster like flood or even light outage that would create communication error. So the 2 UAV style, we will be using one scout drone and one would be delivery drone.
The Scout UAV drone is basically for our detection work, where we are detecting the victim which is in the ground, and for the delivery it would be basically delivering the payload which our drone would be dropping. Next one.
Disasters can be of many types. Some can be man-made or some can be natural. Like flood, we can't control it, but we can control how we respond. Currently, the response time for these disasters is very terrible. Like we have seen in the news, it takes several days to reach the flooded areas, and even army getting included. So, our project is based on helping them in the immediate need, like sending them first aid kits. So our scout drone would go and it will do the scouting for the people stuck, and then the delivery drone would reach the place and drop the necessary aids required for the disaster. Like in floods, we can drop food supplies. The problem statements for this would be the traditional UAV lacks the design and capability to hold the certain amount of materials. And yes, sir. One more problem it is that it requires a low range frequency network, which is not currently used in the disaster management, so we are using it.
So our basic objective is for the disaster management, where we are developing an AI-enabled 2 UAV system for detection as well as payload delivery. So the research questions were that how can 2 UAV coordinate autonomously? So there we are using YOLO V8 and mobile net, for which the communication is very easy between them and the coordination doesn't lag. Also, the major limitations we identified in the previous research papers were the dependency on cloud, like they were heavily dependent on the cloud and they required high net for it.
2 drones. The Scout UAV uses RGB and IR cameras to detect and perform the aerial mapping for the victims, which can be detected using like YOLO and mobile net. The delivery UAV uses A-star, RTT and Dijkstra for optimal route planning. The workflow would be to the takeoff, then sensing, detection, coordinate transmission, autonomous drop and execution. Jetson Nano would be used to provide the faster AI processing.
proposed model, and the we are talking about is about the dual UAV system, where the Scout basically is on the mapping and geolocation, the delivery focusing on optimized location and payload. Like we mentioned, the algorithms we are using for finding the shortest way to reach to the person, to the victim, and then drop the required. So these are the pictures while we were testing our models. These are our pictures only about our hardware drone, and the result and the analysis that we got were the aerial mapping and the visualization we are, and the payload delivery where the accuracy was plus minus 2 or 3 meters. And if we talk about the range of how much distance our drone can cover, it depends on the network. While it is attached to the network, go until and unless the networks drop. But if we on a numerical category or a numerical value if we have to give, so it would be around 1 to 2 kilometer, where we use waypoint navigation, and we fix the coordinates and we train the drone accordingly, and it was going to move and drop the packages where we have scheduled for it.
The synergy between two UAV reduces the mission time. Will be continuing to do the scouting, and the payload will start immediately. It won't take time for all the all the areas to be covered. Start working as soon as it receives the first coordinate. Using Edge AI, remove dependency on the cloud services, improving reliability. As we discussed, that there are not many places which have internet. Future scope would be to add a swarm of delivery drones and scouting drones to increase the speed and area coverage, and add LiDAR for the better map scanning, used for different materials also. Like after the damage or floods, we can also send the data to government to start exact as.
How do you fix up the coordinates?
Sir, actually, how we would fix the coordinates, that would be
In the flood area.
in the.
Is it continuous mapping or coordinate?
Sir, the scout drone would, wherever it detects the human, it will go there, take the coordinates of that area, and send it to the scout delivery drone for the delivery.
It detects the UAV.
Yes, sir. It will detect the human being or any SOS signal which it receives. What's that?
The cluster mapping. Cluster mapping.
So for now, like we haven't implemented it much, so we can't say. But what we are focused upon is, I told about the waypoint navigation, where we would be fixing the coordinates accordingly, and like we can, pehle se like we can plan the things.
Thank you, beta. Thank you, sir. Presentation completes the technical paper presentation. Now let me move to the next part of this session. Now I request Dr. Selja Jain ma'am, Dr. Sakshi ma'am, Dr. Lalit Rai sir to felicitate our session chair sir, Dr. Professor Jamwar sir, with a memento. Please join Sakshi ma'am's. Obra sir. Sir.
I am here, sir. Especially came back.
फोटो ਉਹਦੀ ਭੇਜੀ ਹੋਈ ਹੈ ਪਤਾ
Smile adds grace to personality. इस तरफ आ जाइए चीज बटर में चीज नहीं है बटर में तो बंद हो जाता है प्लीज कम फॉर टी
For next session, Dr. Vandana will moderate, will join shortly with us. You all are invited for a tea. Dr. Vandana. Within 5 minutes we will start.